Hi, welcome to my analytic geometry class. For this course, you should have at least taken algebra for you to get the most from this course. Analytic geometry is also known as coordinate geometry, or analytic geometry is also known as Cartesian geometry, because in analytic geometry we study the graphs of equations that can be drawn in the Cartesian plane or the two-dimensional coordinate system or rectangular coordinate system. In analytic geometry, we will study plane figures in the two-dimensional space. The French mathematician René Descartes was considered as the father of analytic geometry. Hence, this course was named after him. This course, analytic geometry, is known also as Cartesian geometry. And what is the Cartesian plane? The Cartesian plane is a two-dimensional space. The Cartesian plane is a two-dimensional space. It's a two-dimensional space because this coordinate plane consists of two axes. The horizontal axis is denoted by x. In the horizontal axis, we have the set of real numbers. In the vertical axis, we also have a set of real numbers. And the vertical axis is denoted by y. X is a set of real numbers. Y is a set of real numbers. If we take the cross product of the set of real numbers with itself, we will get the two-dimensional space or the Cartesian plane as a set of ordered pairs of numbers. If we write R cross R, the result is the Cartesian plane denoted by R to the power 2. R here is the set of real numbers in the horizontal axis denoted by x. The second R here is also the set of real numbers in the vertical axis denoted by y. And the cross product of R, the set of real numbers, with itself, the set of real numbers, is denoted by R to the power 2, and it is the Cartesian plane. The Cartesian plane is a set of ordered pairs of numbers, or we simply say the Cartesian plane is a set of points. The Cartesian plane R2 is a set of ordered pairs of numbers. These ordered pairs of numbers are points in the Cartesian plane. The Cartesian plane consists of infinitely many points. The first number is known as the abscissa of the point. We take any point in the Cartesian plane. So point P is an arbitrary point in the Cartesian plane. The first coordinate of the point is known as the abscissa of the point. Abscissa refers to the first coordinate of a point in the Cartesian plane. The abscissa gives the distance of the point from the vertical axis or the y-axis. The distance of this point from the y-axis or the vertical axis is the abscissa of the point. If the abscissa of the point is positive, that means the point is to the right of the vertical axis. The real numbers from this point of intersection of the x-axis and the y-axis, the numbers to the right of this point of intersection are positive. So this point has a positive abscissa and the point is to the right of the vertical axis. If the abscissa of point P is negative, that means the point is to the left of the y-axis. The numbers from to the left of this point of intersection are negative. The second coordinate of point P, y, is called the ordinate of the point. The second coordinate of point P is known as the ordinate of point P. So point P has two coordinates. Any point in the Cartesian plane, also known as the coordinate plane or the rectangular coordinate system, or the two-dimensional space R2, has two coordinates. The first coordinate is x. It is called the abscissa of point P. The abscissa of point P gives the distance of point P from the y-axis. The second coordinate of P, called the ordinate of P, gives the distance of the point P from the horizontal axis or the x-axis. So this length is y, and it gives the distance of the point P from the x-axis or horizontal axis. And the length of this line segment is x, the abscissa of point P, and it gives the abscissa of point P gives the distance of point P from the vertical axis or the y-axis. Because the point P is above the horizontal axis or the x-axis, the ordinate of P in this example is positive. If the ordinate y of the point is positive, that means the point is above the horizontal axis or the x-axis. The numbers from this point of intersection of the two axes, the numbers above this point of intersection of the two axes are positive. The numbers on this part of the y-axis are positive, and the numbers below this point of intersection of the two axes, the numbers in this part of the vertical axis are negative. If the ordinate of point P is negative, that means the point P is below the x-axis or horizontal axis. It can be in this side to the right of the y-axis or to the left of the x-axis. Again, the Cartesian plane can be given as the cross product of the set of real numbers with itself, denoted by r squared. The Cartesian plane is a set of ordered points where the abscissa and the ordinate of the points are real numbers. This point is an ordered pair of real numbers. For each point, there is always a pair of real numbers. Those are the abscissa and the ordinate of the point. And this point is said to be an ordered pair because the ordering of the abscissa and the ordinate matters. If you interchange the ordinate and the abscissa, you will get a different point in the Cartesian plane. Next, we will take the distance between 2 points on the Cartesian plane. Before we derive the formula for getting the distance between any 2 points in the coordinate system or Cartesian plane or rectangular coordinate system, let me give you some other properties of the Cartesian plane. At the intersection of the horizontal axis or the x-axis and the vertical axis or the y-axis is the point which we call the origin. The point of intersection of the horizontal axis x and the vertical axis y is called the origin. This is the origin. At the origin, the abscissa of the origin is 0. That is, the value of x is 0. And the ordinate of the origin or this point is also 0. That is, the value of y is 0. And with reference to the origin, the numbers to the right of the origin on the x-axis are positive real numbers. And also with reference to the origin, the numbers on the x-axis that are to the left of the origin are negative. With reference to the origin, the numbers on the y-axis above the horizontal axis are positive. And the numbers below the x-axis are negative. The numbers on the y-axis below the x-axis are negative. The Cartesian plane is, as you can see, is divided into 4. And we call these quadrants. This is the first quadrant. The quadrants are counted beginning from this quadrant in counterclockwise direction. So this is the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. Each quadrant is a set of ordered pair of real numbers, and each quadrant is a subset of R2 or the Cartesian plane. Take the first quadrant. Any point in the first quadrant has a positive abscissa and a positive ordinate. That means all the points in the first quadrants have positive abscissa and positive ordinate. In the second quadrant, if you take a point in the second quadrant, the abscissa of a point in the second quadrant is negative. And the ordinate of a point in the second quadrant is positive. In the third quadrant, the abscissa of any point in the third quadrant is negative. And the ordinate of a point in the third quadrant is also negative. In the fourth quadrant, the abscissa of a point in the fourth quadrant is positive, while the ordinate of a point in the fourth quadrant is negative. Again, in the first quadrant, the abscissa of a point in the first quadrant is positive, and the ordinate of the point in the first quadrant is positive. In the second quadrant, a point in the second quadrant has negative abscissa, while the ordinate of a point in the second quadrant is positive. If you take any point in the third quadrant, the abscissa of a point in the third quadrant is negative. and the ordinate of a point in the third quadrant is also negative. In the last quadrant, the abscissa of a point in the last quadrant is positive, while the ordinate of a point in the fourth quadrant is negative. To get the distance between 2 points, we will take 2 arbitrary points in the Cartesian plane. We take 2 arbitrary points in the Cartesian plane and we denote them by P1 and P2. The points P1 and P2 are elements of R2, which means that P1 and P2 are points in the Cartesian plane or the coordinate system denoted by R2. In particular, the coordinates of the point P1 are x1 and y1. The abscissa of P1 is x1. The ordinate of the point P1 is y1. But we do not exactly know the values of the numerical values of the abscissa and ordinate of point P1. We denote the coordinates of the second point P2 by x2 and y2. That is, x2 is the abscissa of the point P2 and y2 is the ordinate of the point P2. To simplify our derivation of the distance formula, we take these 2 arbitrary points P1 and P2 in the Cartesian plane as 2 points in the first quadrant. We draw the Cartesian plane. In the horizontal axis, we write the variable x. In the vertical axis, we write the variable y. At the intersection of the horizontal and the vertical axis is the origin. And we take P1 and P2 as 2 points in the first quadrant. This is P1, a point in the first quadrant. If P1 is a point in the first quadrant, that means the abscissa x1 of P1 is positive, and the ordinate y1 of P1 is also positive. And we take this point as the point P2 with coordinates x2 and y2. x2, y2. Because P2 is a point in the first quadrant, the abscissa of P2, x2, is positive. And the ordinate of the point P2, y2, is also positive. And we want the distance between these 2 points, P1 and P2. We connect these 2 points with a straight line, and it is called a line segment with endpoints at P1 and P2. To derive the distance formula that will give the distance between P1 and P2, we will construct a right triangle by constructing a horizontal line that will pass through P1 and is parallel with the x-axis. We do that. Draw a horizontal line passing through the point P1 and parallel with the x-axis. Also construct a line, a vertical line passing through the point P2 and parallel with the y-axis. Construct a line through the point P2 parallel with the y-axis and perpendicular to this line through the point P1 and parallel with the x-axis. We do that. Construct a line passing through the point P2 parallel with the y-axis and perpendicular with this line through the point P1. So at the intersection of this vertical line through P2 and the horizontal line through P1 is a right angle, which we denote by a square, a small square, which indicates that the angle at this point of intersection of the line through P2 and the line through P1 is a right angle. You can see we have drawn a right triangle, and from this right triangle you can see that the distance between P1 and P2 is actually the hypotenuse of this right triangle, and we denote this hypotenuse by D, and we want to find the value of D, the hypotenuse of this right triangle, which will give the distance between the points P1 and P2. Now we get the lengths of the legs of this right triangle. If this is the hypotenuse of this right triangle, this side of the right triangle and this side of the right triangle are called the legs of this right triangle. We start with this leg. We find the length of this leg of this right triangle. We find the distance from this point to this point of intersection of this vertical line through P2 and the horizontal line through P1. You can see that the abscissa of the point P2, x2, is the distance of P2 from the origin, and it is given by x2. The distance of P1 from the vertical axis is given by the abscissa of P1, x1. From the origin to the point P2, the distance of P2 from the origin is x2. The distance of P1 from the vertical axis is x1. So from this diagram, the distance, the length of this leg of the right triangle is equal to x2 minus this leg x1. The side of the right triangle, the length is equal to x2 minus x1. Now we get the length of this side of the right triangle. You can see that from the distance of P2 from the horizontal axis x is given by the ordinate of P2, y2. So from the horizontal axis to P2, this length is equal to y2. And the distance of P1 from the horizontal axis or x-axis is given by the ordinate of P1, y1. Hence, the distance of the point P1 from the horizontal axis, this length The distance of P1 from the horizontal axis is y1. So you can see from this diagram that the length of this leg of the right triangle is equal to the distance of P2 from the horizontal axis y2 minus this y1, the distance of P1 from the horizontal axis. Therefore, this side of the right triangle has a length of y2 minus y1. We now have the three sides of the right triangle. The two legs have lengths of x2 minus x1 and y2 minus y1. And the length of the hypotenuse is the distance that we want between the points P1 and P2. With these three sides of the right triangle, we apply the Pythagorean theorem. And the Pythagorean theorem says that the square of the hypotenuse is equal to the sum of the squares of the lengths of the sides or the lengths of the right triangle. Again, Pythagorean theorem says that the square of the hypotenuse is equal to the sum of the squares of the lengths of the legs of the right triangle. And we write that in symbols by Pythagorean theorem, the square of the hypotenuse in this diagram, in our example, the hypotenuse is D. The hypotenuse is the side opposite the right angle of the right triangle. By Pythagorean theorem, the square of the hypotenuse D, we write D squared is equal to the sum of the squares of this side and the length of this side. The length of this side is x2 minus x1. x2 minus x1 square it plus the square of the length of this leg of this right triangle. The length of this leg is y2 minus y1 squared. This is the Pythagorean theorem in symbols. The square of the hypotenuse is equal to the sum of the squares of the legs of the right triangle. And from this equation which we obtained by Pythagorean theorem, we can now solve for the distance D, the distance between the points P1 and P2, by getting the root of both sides. We take the root of the left side and the root of the right hand side. So the distance between the points P1 and P2 is given by the root of the square of the difference between the abscissas of the 2 points plus the square of the difference between the ordinates of the 2 points. This equation is known as the distance formula. We now take an example for getting the distance between 2 points in the Cartesian plane. Consider the following example. Example, find the distance between negative 2, 3 and 1, negative 2. Plot the points and check your answer. The given 2 points, when we derive the distance formula, are denoted by P1 with coordinates x1 and y1, and the point P2 with coordinates x2, y2. With these two given points, we derive by Pythagorean theorem that the distance between P1 and P2, denoted by D, is equal to the root of the sum of the square of the difference between the abscissas of these 2 points, which we write as x2 minus x1, plus the square of the difference between the ordinates of these 2 points, which we write as y2 minus y1. In using this distance formula with these 2 given points, you can take this point negative 2, 3 as the point P1, and this point 1, negative 2 will be your point P2. But you can also take the second point 1, negative 2 as your point P1, and negative 2, 3 will be the point P2. I will take the point negative 2, 3 as the point P1. So P1 is the point negative 2, 3. This implies that the abscissa x1 is equal to negative 2. x1 equals negative 2. And the ordinate y1 is equal to 3. y1 equals 3. If this is your P1, then the point 1, negative 2 is your P2. Our point P2 is the point 1, negative 2. And this implies that the abscissa x2 of P2 is 1. x2 is 1. And the ordinate y2 of P2 is negative 2. y2 equals negative 2. Now we have all the values we need to substitute in the distance formula. So we substitute the values. The distance d between P1 and P2 is equal to the root of open parenthesis x2, 1, minus x1, negative 2, negative of negative 2, and then square it, plus y2 equals negative 2, minus y1, 3, minus 3 squared. The following steps will be simplifying this equation. We have d equals the root of, we have open parenthesis 1, negative multiplied by negative is positive 2 square, plus negative 2 minus 3 equals negative 5 squared. And we simplify further. D equals square root, the root of 1 plus 2 is 3 squared, plus the square of negative is positive times the square of 5, 25. So the square of negative 5 is 25. Or D is equal to the root of 3 squared is 9 plus 25. Or D is equal to 9 plus 25 is 34. We are not given the units. We simply write the distance between the given 2 points is the root of 34. Now, any positive real number has actually two roots, the positive root and the negative root. Example, the root of 9 is, the roots of 9 are plus and minus 3. But for the distance, we only take the positive root. And the positive root of 34 is called the principal root of 34. So if you want to write your answer using two decimal numbers, two decimal places, you take the positive root of 34 and round it off to two decimal places. Now suppose you take the point 1, negative 2 as your point P1 and the point negative 2, 3 as your point P2. Will you get the same answer? We will do that now to check if we will get the same answer. Again, we get the distance between the two given points, negative 2, 3, and 1, negative 2. But this time, we take the second point, 1, negative 2, as the point P1. We take P1 as the point 1, negative 2. And this implies that the abscissa x1 of P1 is 1, x1 equals 1, and the ordinate y1 of the point P1 is negative 2. We write y1 equals negative 2. If this point is your P1, then the point negative 2, 3 must be your point P2. The point P2 now is the point negative 2, 3. And this implies that the abscissa x2 of P2 is negative 2. x2 equals negative 2. And the ordinate y2 of the point P2 is positive 3. We write y2 equals 3. In the distance formula, we substitute these coordinates of the 2 points. We have D, the distance between the two given points, is equal to the root of quantity x2, negative 2, minus x1, positive 1, minus 1, to the power 2, plus the square of y2, 3, minus y1, negative 2. minus y1. y1 is negative 2. We write negative of negative 2 squared. And we simplify the expression is sign the radical sign. Distance d now is equal to the root of the square of minus 2 minus 1 is negative 3 squared plus 3 negative times negative 2 is positive 2 squared. And we simplify further. We have the distance between the two given points is equal to the root of the square of negative is positive. The square of 3 is 9. Hence, the square of negative 3 is positive 9 or 9 plus 3 plus 2 is 5 square. 3 plus 2 is 5 to the power 2. Or the distance d is equal to the root of 9 plus the square of 5 is 25. Or d is equal to the root of 9 plus 25 is 34 units. The distance between the two given points is square root of 34 units. Again, if you want to extract the root of 34 and you round it off to 2 decimal places, take only the principal root of 34 or the positive root of 34 for the distance between the 2 points. So you can see from this result that regardless of which of the 2 given points you take as P1 or P2, you will get the same result for the distance between the 2 given points. Now we will check our answer by plotting the 2 given points in the Cartesian plane. And we check our distance, the distance we obtain using Pythagorean theorem. Now we check if the distance we get between the points negative 2, 3 and 1, negative 2 using the distance formula is correct. And we check it by using graph. First, we plot the 2 points given, negative 2, 3, and 1, negative 2 in the Cartesian plane. Again, in the horizontal axis, we write the variable x. And we call this horizontal axis the x-axis. In the vertical axis, we write y, and we call this the y-axis. And we label the point of intersection of the 2 axes as the point 0 to indicate the origin. And I will use 1 unit intervals to plot the points negative 2, 3 and 1, negative 2. That is, I will use 1 unit on the horizontal axis, and I will use 1 unit intervals in the vertical axis. First, we plot the point negative 2, 3. This point with negative abscissa and positive ordinate is a point in the second quadrant. From the origin, we count 2 units to the left because the abscissa of this point is negative 2. From the origin, count 2 units, 1, 2, to the left. And from this point, you count 3 units upward. Because the ordinate of this point is positive, from negative 2, we count 3 units upward. Again, to plot this point, you count 2 units from the origin to the left, because the abscissa of this point is negative. So we count 2 units from 0, 1, 2, and from this point you count 3 units upward, because the ordinate of this point is positive 3. And we arrive at this point. This is the point with coordinates negative 2 and positive 3. Next, we plot the second point, 1, negative 2. To plot this point, you start with the abscissa, count 1 unit from the origin, and because it's positive 1, you count 1 unit from the origin to the right, and you arrive at this point. And from this point, you count 2 units downward, because the ordinate of the second point is negative 2. That means the point is below the x-axis. Again, count 1 unit from the origin to the right. And from this point, you count 2 units downward. 1, 2. And we arrive at this point, the second point given with coordinates 1, negative 2. And we want the distance between these 2 given points. We connect them with this straight line. And we find the distance between these 2 points. As we have done when we derive the Pythagorean theorem, we construct a right triangle from these 2 points. From this point, you draw a line, horizontal line, parallel with the x-axis. Construct a horizontal line passing through this point and parallel with the x-axis. And from this point, you draw a vertical line passing through this point, parallel with the y-axis and perpendicular to this line, passing through the first point. And we draw this vertical line passing through this point, parallel with the y-axis and perpendicular to this line. So at the point of intersection of this horizontal line and this vertical line is a right angle. This point is 3. Now we have a right triangle. Again, you can see the distance d that we want is the hypotenuse of this right triangle, because it is the side opposite the right angle. Now we find the lengths of these 2 sides of the right triangle. We start with this side of the right triangle through this point and this point at the right angle. When you get the distance between 2 points on a vertical line, you get the difference of the ordinates, because these 2 points have the same abscissa. The difference of the abscissas of these points is 0. And that simplifies the method for getting the distance between 2 points on a vertical line. Just get the difference of the ordinates. And you start with the ordinate of the higher point. At this point, the ordinate is 3. Minus the ordinate of the lower point. At this point, the ordinate is negative 2. The ordinate is negative 2. 3 minus negative 2. And we simplify, we get 3 minus negative 2, or negative times negative is positive 2. And 3 plus 2 is 5. Next, we get the distance between these 2 points. That will give the length of this side of this right triangle. These 2 points are points on the same horizontal line. So this point and this point have the same ordinate 3. And when you get the difference of the ordinates of this point, you will get 0. And that again simplifies the method for getting the distance or the length of the line segment between the 2 points on a horizontal line by just getting the difference of the abscissas of the 2 points on the horizontal line. And when you do that, you start with the abscissa of the point to the right. At this point, the abscissa is 1. This is 1. So the length of this side of the right triangle is 1 minus the abscissa of this point. The abscissa of this point is negative 2. 1 minus negative 2. And we simplify, we get 1 negative times negative 2 is positive 2. And 1 plus 2 is 3. Now we have all the lengths of the 3 sides of this right triangle. Although the length of the hypotenuse T is still unknown because it is what we want. But the 2 legs of this right triangle, their lengths are now known. The length of this side is 3, and the length of this side is 5. And to find the value of D, or the distance between these 2 points, we use the Pythagorean theorem. We write by Pythagorean theorem, The Pythagorean theorem says the square of the hypotenuse is D, and the square of D, we write D squared, is equal to the sum of the squares of the 2 other sides. We start with this side. This side has a length of 3, and square it, plus the square of this side. We have shown the length of this side is positive 5. Square it. So this is the equation we obtained by Pythagorean theorem. The square of the hypotenuse D is equal to the sum of the squares of the 2 other sides, 3 and 5. And we simplify. We have D square equals square of 3 is 9, plus square of 5 is 25, and 9 plus 25 is 34. And that is the square of D. And to find D, we extract the root of both sides. The square root of D squared is D, equals, this implies the square root of D squared is D, equals the root of 34. We simply say units. So we have shown that the answer we obtained using the distance formula to find the distance between these two given points is correct because we have checked it by calculating the distance between the two given points from the graph and using Pythagorean theorem. For your practice, you may want to try the following exercises. Find the distance between the 2 points. Plot the points and check your answer. You will do this for each of these two numbers. In number 1, the 2 points are 3, 1, and 1, 5. You will get the distance between these 2 points using the distance formula, and you will check your answer by using graph. You plot the 2 points, construct the right triangle, and apply the Pythagorean theorem. For number 2, the 2 points given are -2, -2, and 2, 4. You will find the distance between these 2 points using the distance formula. And again, you check your answer from using graph. Plot these 2 points, construct the right triangle, and apply the Pythagorean theorem. For our lesson 2, we will take up the midpoint between 2 points. If you have any question for today's lesson, you write your question in the comments below. And do not forget to subscribe to my YouTube channel, Cartesian. Thank you for joining my class in Analytic Geometry today.